All right. Bismillahirrahmanirrahim. Assalamu alaikum. Once again, let me open a new sheet. All right. So I think for this one, just let me take one example from my own without. Suppose I have this circuit. Let's say one. Right. So, and in this particular question, assume that initial conditions are 0. So V0 is 0 and I0 is 0. In this case, if you remember that we do not need to add the current or voltage source as I showed you. Can I use? Like this one, we don't need to add for capacitor a current source or a voltage source. Similarly, not. So first thing is to convert this into Laplace domain, S domain. So it will be, remember that XC is 1 upon SC and XL is SL. So S is S and L is 2 for this one. And it will be 1 upon S times 1. And if you remember, I think it's upon S square plus 4, 2 times, if I'm not mistaken, there will be a 2 here. Yes, can be. Just a minute, let me just confirm. Sine omega t is omega upon S square plus omega square. Here in this case, omega is equal to 2. So omega, this is omega and this is omega square. This will remain 1 and this will remain 1. We can apply nodal analysis in this case very simply. So let's call this V1 maybe. So we can write the node equation as V1. This will be capital in terms of V1. So V1 minus 4 upon S square plus 4 divided by 1 for this current plus V1 upon S plus V1 upon 1 upon S is equal to 0. So this is the simplest case that one would expect. There is no initial condition, no complication, no switch, no control source, nothing. So this is the easiest. I think this we can easily proceed without any complication. Any question in this thing? Very basic, just to start, very basic thing.
Sir, it's not S2, sir, for V1 over S, not S2, sir.
Yes, so there will be 2S. Like this?
Yes,
okay
sir.
now? Okay, thank you.
Okay.
Thank you, Pranjal. So just one variable, one equation, you can solve it, no problem. So this is the basic thing. Once again, to transform the circuit into Laplace domain, We have transformed the source into Laplace. We have transformed the inductor into Laplace, capacitor into Laplace. Very easy, no problem. The things to highlight or to note is when we have a source in a particular shape, or we have some initial conditions to consider. So we need to make sure to note these particular things. Right. Let me add another slide. All right. And before so I'm opening chapter 16. What happened? Yep. Chapter 16 is the applications of Laplace transform. So let me just go to the problems. Let's say okay, I'm scrolling the figure and you can maybe ask me where to stop. Okay, I'm going slowly, starting from the problems. Okay, can let me know where to stop. Anyone? Please, anyone? I'm waiting for your response. Can you guys hear me?
So question 25.
25. This one. All right. Okay. First, let's discuss it here first before I go to the solution. We want to find out VT, which is this voltage. Okay, we want to find this particular voltage in this question. Can anyone tell me what is the difference in this question and the previous question? Can anyone tell me what is the difference in this question and the previous question, the one that we just did?
So the initial condition.
Yes. How do we know that there is initial condition?
When t equals to 0, it becomes open circuit.
All right, very good. So we can see that this switch was closed before t equal to 0, and at t equal to 0, the switch is opened. All right. So what will happen that this voltage source is with the whole circuit. Okay. So we remember from the circuit theory that for a DC source, this is a DC source by the way. For a DC source, the inductor becomes short circuit and the capacitor becomes open circuit, right? So we need to find this voltage, which is V0, and we need to find this current as well, by the way. This current for I0 and this current for this voltage for V0. Once we have this one, we can proceed with the normal circuit analysis by replacing those values in the circuit elements we just like learned about, right? Can I copy this thing from here? Can I? How do eraser? Cannot copy it, right? So let me try to. Okay, let me just try to draw it here. Why can't I go up? Okay, I'm drawing the circuit with at t less than 0. So it will be the switch is closed. The inductor is short circuit, you can see, and the capacitor is open circuit. And this is the circuit that we are looking at: 60, 12, 6, 15, 25, right? What we need to see is what is this current and what is this voltage. All right. Looking back at circuit theory, I can easily say that I0 is how much? Parindra, what do you think? What will be the value of I0 by inspection only? We have a 24-volt source, 6 ohm resistor over there. What will be I0 by inspection?
0, sir, because the switch is
it's
open.
Okay, no, wait. Please relax. Switch, where is the switch? This switch or something else? Which switch you're talking about?
Yeah, that switch. Or maybe it's because the circuit is open there at the.
Yeah, it's open circuit here.
Drawing.
Okay, it's open circuit here, so no current can pass through, right? So
yeah, right.
I0 equal to 0. Okay. How about V0? Which circuit element can give us V0? Someone else? Where is the list? It's here. Okay, get ready to answer. Sharif, how do you find V0 in here? Sharifuddin? Sharifuddin, are you there?
Yes, sir.
Yes. How do you find V0 from this circuit? Sharifuddin unmuted, said yes, sir, and again.
Hold on, sir. I'm thinking.
Are you here or doing something else?
I'm
playing
here.
Playing PS4, FIFA.
Oh, I'm here. Actually,
Okay.
I just came out of the toilet, so I'm
See?
lost.
Okay,
So,
Mustaqim, can you unmute and let us know, how do we find V0? Mustaqim, are you there? Okay, any volunteer? Atika Farzana. Nur Atika Farzana, can you unmute your mic and please let us know? Guys, you have to respond to the questions. You have to make it as interactive as possible.
Distribution, sir.
Okay, Hang Chin Tian, you were saying something?
So I said voltage division.
Voltage division, okay. Okay, we can apply voltage division. We have this voltage source, and maybe it is divided in this resistor and the combination of this resistor, like this one and this one, if this is what you mean.
Yes, sir.
Okay. So I think 6, 12, 66, 15, 25. Twelve, 60, 25, 6, and the other one was we're doing 16.25. Taking too much time. 15. All right. So we are looking for this voltage just to, because this is important, because in the questions, the initial conditions might not be given. So just to give you a recall, whenever there is an open circuit, okay, you go back to one branch, one end of it, and go back to the other one, regardless of this thing, because it is open circuit, there is no current here, so we have to go back to this one. So we are looking for this voltage actually. Do you guys agree with this? That whenever we're looking for an open circuit voltage, we consider the elements connected in series. This one also ignored because there is no current. So open circuit voltage we find out like this. Do you agree with this? I need your agreement on this one, all of you.
Agree, sir. Agree.
All right. So we can find the VO, let's call it VO, which is actually this voltage equal 60 parallel with 40 divided by 12 plus 60 parallel 40 times 24. What did I do? I added these two in series. 40. This 40 and this 60 are in parallel. Okay, so resultant is, this is 60 parallel 40, and this is 12, 24. So we can get VO equal like this. Do you understand this one?
Yes,
You guys
sir.
all agree? Anyone, any problem in this one? This is important because we need to find the initial conditions and then we apply it to the circuit. So somebody can find 60, 40, something. Can someone find it out? I don't have it. I don't have a calculator right now. Can someone give me the value?
Two 2.67.
2.67. 2.67 is the voltage. Okay.
16, sir. 16.
It cannot be 2.67. volts. All right. So now how to proceed is to use these values and this value using the circuit elements. Which ones? These. Do you have someone all together? So the capacitor, we have the voltage, we can either use this one or we can use this one. Since this is adding one more of the S, I think this would be easier, that if we add a current source in parallel, maybe, or actually that depends. It depends on how we want to replace that thing. Similarly, inductor, luckily for us, that I naught is 0. Where is it? Why is it not showing? So this is 0, so there's a short circuit there. So there will be a short circuit because I naught is 0, right? So if I go back to the question, where is it? All right. Not enough space. And then there was this inductor with a short circuit, and then a capacitor. So what do you want to keep? A current source or voltage source? Tell me. What do you want to keep? A current source or voltage source? Anyone? That's up to you actually. Can anyone suggest me? Can anyone suggest me to keep voltage source or current source together with this capacitor?
Voltage source.
Voltage source, okay. Let's keep the voltage source with that. When we keep a voltage source, it has to be inserted in series with the capacitor. How much was the capacitance value? 1/27. And inductor was 3 Henry, so 3S. V naught was 16. All right. So this will be 27 upon S. I'm simplifying it. Right. So this is it. Now we're considering at t equal to and greater than 0. So what will happen to the circuit on this side? This is open circuit, so this is all gone. So we're only left with the circuit here. All right. And we need to find out the capacitor voltage plus minus V naught. Is it V naught? Just V only. All right. So just to make it clearer, eraser, everything from here. Oh, this has to be there. Oh, we removed a lot of things. All right. So any suggestion how to proceed? Any suggestion how to proceed? We're looking for V naught, this V. Can we apply maybe mesh analysis? I1, I2. Applying mesh analysis, you can use any method, by the way. So if we apply mesh analysis for I1 will be 60 I1 plus 6 I1 minus I2 plus 3s I1 minus I2 plus 27 upon s I1 minus I2 plus V0 was 16, so 16 upon s equal to 0. This is for mesh 1, and this is mesh 1. Mesh 2 is, I'm adding 15 and 25, so 40 I2 minus 16 over s plus I2 minus I1 27 upon s plus 3s I2 minus I1 and plus 6 I2 minus I1 equal to 0. So far so good. So I think this was the most difficult part, that to find the initial conditions. Then you replace the circuit elements with the equivalent models for initial conditions and then write the equations. The rest is just solving the equation. So we need to find I1 and I2. Once we have I1 and I2, we will be I1 minus I2 times 27 upon S will be their solution. And of course, this is Vs. Then we take Laplace transform, Laplace inverse to get Vt. Is that clear? Let me see if there's a question anywhere. Okay, no. Can I get a raise of hands if everything is okay? Okay. Okay. Thank you. Thank you. All right. So I believe the most important part is to find the initial condition and put it in the circuit together with the actual question. All right. Let me move to another type of question in which there is no switch. Where is it? It's here. How do I go out of it? Okay. So maybe let me, okay, this one maybe. Okay, what do you see here? What do you see? What's maybe new that we have not seen so far? Anyone? What's something new here?
So it's u minus t.
U of minus t. Very good. U of minus t is basically, if I can write, U of t is something 1 and 0, t greater than equal to 0 and t less than 0. If it's minus t, it's the opposite. So if ut is like this, u of minus t is like this. And it shows something like a switch. Even this is a switch. This is a switch that it is off, like it's open circuit before t equal to 0 and it's on at t equal to 0. This is the opposite. This is on before t equal to 0 and off after t equal to 0. What it has implication on the circuit is that it is available before t equal to 0, which means that capacitor and inductor are fully charged. And that will result in some initial conditions, right? This means we are considering once again a similar circuit with initial conditions. We have to replace them, and then we have to place the initial conditions, those current and voltage sources, and that's it. So let me just do it quickly. When this source is there, basically it's just 20 times 1. So it's just 20 volt source. It is connected. The capacitor is fully charged. Inductor is fully charged. This is short circuit. This is open circuit. This open circuit makes this current equal to 0 once again. And we need to find this voltage. This voltage is basically this voltage, because I told you that when we are looking for an open circuit voltage, we remove anything that is connected in series and go back to the other terminal, other side. So we're looking for this voltage. So I'm sure that now you'll be able to say that V0 is equal to 20 volts. Is that okay? And I0 is 0. Very simple. Right? Is it okay? So when we do, this is basically at t less than 0. When it is t greater than 0 or equal to and greater than 0, it will be like this. Will be a plus minus 20 volt 1 upon 4s, and this will be 16 upon s, and this will be 5. I think now it's just history that you apply mesh analysis. So this question introduces, not introduces, you already know that, but this is the first time that you have seen U minus T in place of a switch. Previously, there was a switch. So it is like having just a 20 volt source and a switch that opens at T equal to 0. Do you understand? So a similar question, maybe, let's take this one. This is interesting. I think I'll give you in this slide as well. So if we consider this question, we will be having some initial condition. No, actually there's no initial condition here. Will there be any initial condition in this question? Guys? This is something what I told you yesterday as well, that I'm giving you a capacitor today to test it, but I don't tell you that there are some initial conditions there or not. So there's a similar case. So for such questions in the examples or in the test or whatever, if it is not given and it's not anything, there's no certainty that there will be some initial conditions. Like this source is applied after t equal to 0. This source is applied after t equal to 0, and no such thing given in the question. We will consider that the initial conditions are 0. All right. Is it okay?
Okay, sir.
All right. Mustaqim, you have a question? You're raising your hand, Mustaqim. I want to see a question in which there is a source before and after. You want me to discuss these questions, these two questions? Any of these? Yes, do you guys want me to do this question? Somebody put a message there. No, sir. Okay, sir. No, this is for the previous one. So any one want me to do one of these questions? We have 15 more minutes. I want to go for the transfer function. Okay, which one? Sharif, which one? 38 or 42? Which one? 38 or 42? 42. Okay. Given this circuit, find IT and VT for t greater than or greater than 0. All right. Interesting. Actually, very interesting question. Why? Because we can see that there is this source before t equal to 0. But what will happen when we close this switch? What will happen when we close this switch? Liang Fai Yao. What will happen to this switch, to the circuit when the switch is closed? Liang? Short, yeah, yes, it will be short circuit, very good. So short circuit means that this segment is gone, right? This segment is gone. Somebody wants control? Okay, what is it? Oh, okay, which one of you want control? Does someone want to do this question? Okay, I'm just clicking on the first one. Okay, I'm confused. I'm confused, guys. You want to do it or not? I don't know how to.
No, sir.
Okay, now I don't know how to take control back. Okay. Anyways, no problem. So how to remove everything from here? All right. So previously, before t equal to 0, this source is there. This will be short circuit, and this will be open circuit. So if we are looking for the voltage and current, so this capacitor voltage will be kind of this voltage, and the inductor current will be this current. So it looks like a very simple one. It will be like this. 1 and 2, because this is where the inductor was, and this is where the capacitor was. So plus minus 12, 2. So if we see that there is a 12-volt source for a 3-ohm resistor, so the current is 4 ampere, but I naught will be minus 4. Do you agree? I naught will be minus 4, and the voltage will be equal to this voltage. So this current is 4, and 4 times 1, so this voltage is V naught is 4 volts. Maybe if you are not very volts, and 2 and 1, this is where the capacitor was. Due to the direction of the source, the polarity, the current is like this, plus minus. So I is equal to 12 divided by 3 equal 4, but I naught is The current for the inductor will be -4 because it is in this direction. And V0, we know that this voltage and this voltage are same. We have this current 4 times 1 is 4, so we have I0 and V0 equal to 4. Is that okay? Sharifuddin? Sharif was okay?
Yes, sir.
All right. So now that we have the initial voltages and the current, let me just remove everything. Why can't I delete? All right. So now we have both I0 and V0 as well. Can I insert a voltage source here? Plus, minus, which was C V0 or V0 over S? I think V0 over S. And to introduce current, I have to go back and just get confirmation. Okay. A voltage source also will be negative and positive L I0. Is that okay? And of course, this is short circuit. So this branch is gone. Is it okay, everyone? So the circuit looks like, can I move it a bit? Four upon S, this is in S domain, minus, plus minus, V0 is 4 upon S, 4 upon S, and S, this is an inductor, and minus plus 1 times I0 minus 4, and will be 1. I think this is okay now. We want to find out this current and this voltage. So if we find this voltage here, let's call it V. We cannot call it V, let's call it V1. We can find everything. Can we apply node analysis here? It will be very simple. Can I write equation somewhere? So V1 upon 4 plus V1 minus of minus 4, V1 minus of minus 4 of minus 4. There will be another minus, so it's like plus upon S plus V1 minus 4 upon S upon 4 upon S equal to 0. All right, so we just need to find V1. This is V1. Once we have V1, we can find I and we can find V. Okay, Sharif?
So why is it V1 over 4, sir?
Which one?
The
Sorry, it should be 1. Yeah, right.
Okay.
Thank you. Sometimes it works, sometimes it doesn't work. Thank you. I'm human, okay? All right. Let me move to transfer functions. One question from transfer function. Are we there yet? Okay. Transfer function. Let me. I think these are the 3 questions I gave you for. So let me just go to some other question. Maybe there's nothing value here. Okay, probably. Nope. Okay, let's take this one. Without the value is better. Something without the value. I can't find. Okay, this one. Okay, one thing. Can I just ask once again, what is the transfer function? I have 5 minutes to do this. What is the transfer function? Guys, where is my list? Okay, Jocelyn, what is the transfer function?
Output divided over input and without initial condition.
Wrong. Wrong. Why is it wrong?
It has to be in frequency domain.
Yes, Jocelyn, remember, this is the thing that the interviewer would like you to say, output upon input. It is output upon input, but in frequency domain. Okay, you got the difficult part right, that without initial conditions, like there shouldn't be any initial condition, but make sure that you mention it is in frequency domain or Laplace domain or something, right? Okay. So output upon input. If we say that output upon input, and it is supposed to be an expression. So sometimes, like in this question, although it is given the input, we need to keep the output and the input in terms of output and input. We have to find I upon IS. Okay, so we don't have to insert the value of the input there. We don't have to insert the whatever we find out. We don't have to insert the values here. We have to find out the transfer function h of s equal output in Laplace divided by input in Laplace, right? So I hope I can find some space here. Not enough. All right. So eventually we're looking for h of s equal I of s upon is of s. So these are the variables of interest. Okay, I think this is very straightforward, but let me just go through it quickly. We need to relate I and is, and I think you would appreciate it's very simple if you use current division. We know that is is divided in these branches. So I is equal to 2 upon 1 plus 0.2, so 0.2 s plus 2 times is. It is basically, when we are looking for this current, we need to put this one in numerator, which is coming here, and in the denominator the sum of all the impedance. So this is 1 plus 0.2s plus 2, and now we can say that I upon is is 2 upon 3 plus 0.2s. This is the transfer function. It looked very easy right now, but you don't have to find the value of the input or the output in that case. Let me take one more quick example in which it's a bit okay, maybe this one, a bit complicated at least. So okay, let's say we're looking for this as the output. So output is Vs. Now remember that there are two sources here. Oh, I did not mention this about this one. We cannot, at least at this time, we cannot find transfer function with two sources unless we apply superposition. And I don't want to take you in that trouble right now, because we can, for this particular case, we can find V over, let's call it V1, and let's call it I1. We can find V over Vn or V over I1 as the transfer function, but when we find for V1, this has to be 0, and when we find I1, this has to be 0. Okay, so I'm not going into this one at least today. With one source, okay, let's take this one, although it's so let's find out V0 over Vs. H of S equal V0 over Vs. All right. So we have to relate this one, and looks like if we can find this impedance, if we can find this impedance, converting it to be like this, then this voltage is actually VO because they're in parallel. Okay, so let's find this impedance as Z equal R2 plus SL parallel with 1 upon SC in this case. And once we have this, the Z, we don't need to find Z. So VO is equal to R2 plus SL parallel with 1 upon SC divided by R2 plus SL parallel with 1 upon SC plus R1 times Vs. And of course, the transfer function will be, we just bring this one in the denominator on the other side, we can find the transfer function. Again, it's not very complicated, but I hope you get the idea. We do not want the value of the input, or we don't want to find the value of the output. We want to keep it unknown and put them in a ratio. All right. I'll stop here taking the questions, and I'll go, we'll break into the groups, and then I've already assigned questions, and I hope that you can start discussing, and I'll drop by in different sessions to see what is the problem. Any question before we break? Any question before we break for the teams? Okay, then.
Sir, I have a question,
yes,
sir.
yes.
So, sir, like suppose in one particular jumper cable, there's a capacitor and so
Your voice is breaking, Pendra.
sorry.
Your voice is breaking. Can you say again? Pardon, can you say again? Is it from my side or I'm okay? Can you guys hear me? Or did anyone understand Parinda's question?
That's just why it's like your voice is okay.
Sorry, I don't understand.
Parindra's question was also lost for me, Doctor.
Okay. Parinda, are you there? Okay, I'll come to the group and then you can ask there. Okay, so we break for the group sessions, and I'll join you in a while. All right, thank you. I'm stopping the recording for this one.